Hello, good evening. Hope we are doing well. Yeah, we are going to learn how to check the distributions of our data, or we want to see what is normal distribution and how to check on it. It's very important in statistics in the sense that it is even following some natural process like the age, the height, even the blood pressure, saying that the way human beings or even plants are growing is following normal distribution. Even the blood pressure is following normal distribution. And in statistics, when we are just saying that some tests are not parametric tests, the big condition behind there, when we are talking about parametric tests, we are talking about normal distribution. That's the point. It's for this reason, it's better to understand what is and how also to check on it. Okay. Then let's say that we will be getting something like this. Not only we will be doing numerical tests, and apart those numerical tests, we will be also having some graphical tests like this one, which is called Kipinor. Apart this one, also we can check, yeah, using some graphs like in histogram. It's what we'll be just doing step by step. And now you can see the tests here around here. That's what we'll be doing. Let us now delete whatever we have around here and restart afresh. Then you will follow step by step what we are just doing. For those who have not yet subscribed, please subscribe to our channel. We have a lot of things to learn together. Yeah. From here, I will start importing NumPy, for example, which can allow us now to generate randomly data also. NumPy as or NumPy or importing. Okay, I can say from NumPy random import normal as normal. Okay, that's the point. This one will allow us to generate randomly data. Okay, I need also to from scpy start. Okay, or maybe import Shapiro. Okay, we'll use Shapiro to do a numeric test. Import Shapiro as Shapiro. Yeah, that's the one point. I can execute and see what is happening. After this one, I need also matplotlib. Okay, from matplotlib, which can allow us now to have nice graph around here. Matplotlib pylab import. Okay. Okay, already I can just say that import matplotlib pylab as pylab. Okay, we can also import pyplot, import matplotlib pyplot as plt. Okay, then this one also will allow us now to have just an eye graph after doing numerical test. Okay, and now normally distributed data. Okay, random normally distributed data. We want to generate data which is normally distributed but randomly, for example. Now we can call it now data. Okay, whatever. Now we will use normal log scale size normal. Say in the log is 15, the scale is 5, and the size is 100 around here. Okay, then you can generate this one, and this one is a random data generated, but which is normal distributed, because we are just generating data which is normal distributed. We want to see when data is normal, how we can behave, what is happening. And now, since we have it now, we can now just do Shapiro test. Okay, then from Shapiro test, we know that what we will get like the coefficients of the test. We norm it cough test, and we will be having also p-value, which can allow us to decide. Then we will use now Shapiro and just do that. And Shapiro, after Shapiro, we have just to put our data, which is generated just above there. So what will we have? Then we have to say that whatever the test we are doing, we have null hypothesis. In our case here, the null hypothesis in that data is normally distributed. Okay, I'm not the one deciding about the null hypothesis. For all normal distribution tests, the null hypothesis is data is normally distributed. According to the value of the p-value, we can reject or accept it. Then we have it now. Cough is just this one like this. Now, to print the result, we are saying print our result. We want first you to print the coefficients of the test, coefficients test, and we want to have three figures after the decimal, 3 f. And now after it, I want also you to print p like the same way, three figures after the decimal point. Okay, we have these kind of things now. Okay. Now, the point is, when the p-value we are getting is less than 5%, we are rejecting H naught. And when we are rejecting H naught, we are saying that data is not normal distributed. But when the p-value is greater than 5%, we fail to reject the H naught, or we are accepting the H naught and say data is normally distributed. Then we have to tell Python to do that. If p-value is less than 0.05, which represents 5% here, we want Python to print as data is not normally distributed. Okay, then if it's not that one and it's something which is different, we want also Python to print as that data is normally distributed. Okay, from here now, when it is greater than 5%, this one is generated. Yeah, this phrase is given. But if it's not, this data is not normally distributed, we are rejecting H naught there, which is data is normally distributed. Then when we fail to generate, we fail to reject H naught, we are saying data is normally distributed. What we are telling Python to do for us. Then I can now run, and we'll see what will happen. Okay, we have the result. The coefficient of the test is 0.98 and the p-value is 0.55. Wow. Yeah, we are seeing data is normally distributed. Like what is happening here, this value is greater than what? It's greater than 5%. Then we fail to reject the H naught and we are saying data is normally distributed. We are even expecting it because the data we generated here is normally distributed. It's following normal distribution. That's the point. Then this one is numerical test. We can also do some graphic test, check it graphically and see what is happening. Now from here, you can see test now. Okay. From here now, graphical test now, we can use the QQ norm, the one I was just showing at the beginning. Now we can say stats, probability starts now. Okay. We need to import SIS. Okay. From SI. Okay. I need to import now from even SI stat from SIPI. Yeah. Start. Okay. Or from SPI import. Okay. I can import it right directly. Import SIPI stat as stats. Okay, this one which can allow us to draw quick on test bank. Then graphical test, I will just say, I can just say stats probability, yeah, probability plot. And I will use now the data we generated. The name is data. Then I will say I want it to be generated by plot, by PyPlot. I think PyLab. I think yes, I imported it also. Then plot. PyLab. Okay. Now I want PyLab to show it. Okay, so what is happening around here? Let me run and you will see. Running shift F10 or just go in there and run. That is our Pi probability plot, which is showing us the data normal distribution. As you can see, the data in blue, just around the line, red line. That's the point. And sometimes we are just accompanying the graphical test with the numerical test to be very sure. We can also use histograms to check it also from here. Then at that moment, we can use a Seaborn. I think I imported this Seaborn things. Not yet. Then I need to import Seaborn. Import Seaborn as SBS. Then importing Seaborn from it now SBS. Okay, you can use this plot. It can give me now histograms around here. Our data generated, we called it data. So this I'm just using data around here. Now I think you are getting me. Now I want PLT now to show me it. Yeah. You see, then you see the Python is generating or executing from up to down or being up down system, meaning that whatever we have previously will come first. After it, we have to make it away before to see our histogram around here. That is the distribution. And this one, for example, someone will tell you that me, I cannot see normal distribution there. Another one can see that's normal distributed. So for this reason, always when we are using graphs to make some kind of test, we should accompany them with numerical tests. For this reason, we use Shapiro around here. And we hope that this one will help you. In case you want to know more about this software Python, or maybe it's R software you want to know, or maybe if it's Stata or SPSS, you can just get in touch with us. We are giving such kind of trainings also, so that this one will help you for your study. Thank you so much.